So operations with polynomials. Today our bigger focus is going to be multiplying. We've kind of dealt with the exponents by themselves, addition and subtraction. Now our big focus is multiplying. We've seen it a little bit. So go ahead and try 2x times 3x squared minus 4x plus 10 on your own. This fox is getting excited over here. All right, Emery, when you distributed, what'd you get?
6x cubed minus 8x squared plus 20x.
Good. So he's multiplying the coefficients and adding the exponents like we talked about in that last one. Whoops, I forgot my squared. And then you want to double check, make sure this is in standard form. It is x cubed x squared x. So it's in descending order from the biggest exponent down to the smallest. Well, they are going to get a little bit harder. This was just a monomial times a polynomial, in this case a trinomial. We might have binomials times binomials. We've seen these. For these, Chase, what am I going to use?
Foil.
Yeah, so we'll do this together. We've got m plus 7 times 2m minus 3. Binomial times binomial, we're going to FOIL. Look like you're in your own little world. So we're going to multiply the first, 2m squared. The outer, minus 3m. The inner, plus 14m. And the last, minus 21. And if you actually accidentally do it in a different order, that's not a big deal. We're going to combine like terms, make sure we get it in standard form. So 2m squared plus 11m minus 21. That's in the right order. And usually those two in the middle will be the ones you're combining. All right, so here's another one, but now we've got some exponents involved. So we've got 3x squared minus 5x times x squared plus 2. It's still FOILed, it's just a little bit trickier with the exponents. So we'll go through it together. 3x squared minus 5x times x squared plus 2. It's still going to be FOIL. So when I multiply those, I multiply the coefficients. Well, that's not exciting. We just get 3. Add the exponents, so x to the 4th. I multiply the outer. 3 times 2, so 6, x squared. I multiply the inner. Negative 5, add the x exponents, x to the 3rd. I multiply the last, minus 10, x. Well, it's a little bit different because it wasn't our typical FOIL. Are there any like terms? No. Is this answer okay? No, it's not in the right order, so we better flip it around a little bit. 3x to the 4th minus 5x to the 3rd plus 6x squared, so I had to rearrange those two, minus 10x, because we like this to be in standard form. The biggest exponent down to the smallest, or the highest degree down to the smallest. That's what we went over yesterday. Okay, now this, I don't know that you saw this in Algebra 1 or not. We've got a binomial times a trinomial. And we're going to kind of branch off what FOIL is. FOIL, we get so used to doing it, a lot of times we forget what we're doing. So let me go back to this FOIL problem for a second. And what I was doing here is I took 3x and I multiplied here and I multiplied here. And then if I do this in a different color, I took negative 5x and I multiplied here. I took 3x squared and I distributed. And I took negative 5x and I distributed. So it's going to be the same idea here. I don't have a fancy name to remember it. I don't have FOIL. But I'm going to take x and I'm going to distribute to all three of these. So let's go ahead and do that. So x times x squared, bless you, x cubed. X times 5x, 5x squared. X times negative 3 minus 3x. Then we're going to take, if I can change color, come on. Why won't it let me change?
I think it's blue now. Oh, you clicked it and it turned blue.
That has to turn blue. Oh, let me change all of a sudden. Well, that's annoying. It's not the end of the world. All right, well, I'll just do it in red. So I'm going to take the 2 and distribute all the way through. So 2 times x squared, 2x squared. 2 times 5x, 10x. 2 times negative 3, negative 6. What do you think I have to do next? Yep, combine like terms. And I start with the biggest degree and I work my way down. So I glance through there. It's usually going to be the first one. It is x cubed. There's no other x cubed, so I start with that. Then I've got 5x squared and 2x squared. So that's 7x squared. I've got negative 3x and 10x, so that's 7x. And then I've got negative 6 that I can just bring down. So same idea with FOIL, just it's a little bit longer because we have a trinomial here. Oh, that's not changing. All right, let's try this one. A minus 4 times 2a squared minus 4a plus 3. So same idea, same type of problem. A binomial and a trinomial. A minus 4 times 2a squared minus 4a plus 3. So we're going to take the a and we're going to distribute, and then the negative 4 and distribute. I'm going to give you a chance to get a little head start, and then I'm going to try and catch up. Take the a and distribute, and the negative 4 and distribute. And you hear me say it all the time, but once you get the hang of it, it's probably going to be signs where we make mistakes, so be careful with your signs. When I did all my distributing, I got 2a cubed minus 4a squared plus 3a, then negative 8a squared plus 16a minus 12. So now I'm going to start combining. I have 2a cubed. There's nothing to combine it with. Some people like to cross off as they go. You're welcome to do that. Negative 4 and negative 8a squared, so negative 12a squared. 3a and 16a would give me 19a. and then minus 12. Feel okay with those? Okay. Let's look at these. 3 binomials. We've got n plus 3 times n plus 1 times n minus 2. Well, if I think about multiplication, if I had 3 times 5 times 2, I'm allowed to multiply those in any order. I can't just look at those and multiply all three, bam, all at once. Calculator, I suppose I could, but I can, in my head, I can think, okay, 3 times 5 is 15, times 2 is 30. If I'm doing it in my head, I might choose to multiply 5 and 2 first, because I like that easier to get 10, and that's 30. For some reason, I could also think, hey, I want to multiply 2 and 3 first to get 6 times 5 is 30. You're allowed to multiply in any order, so I can multiply whatever 2 I want first. So it doesn't matter. We can do this lots of different ways. And of course, this isn't working, so I can't erase, so bear with me a minute. Get rid of all that. Okay, so I can do this in any order. Personally, what I would do is I would multiply these two first. And I'll show you why after we multiply them. So you can pick any 2 you want, but I would multiply the last 2. So let's try that. So the first one, pretend it's not here. If I just had n plus 1, n minus 2, what am I going to use to multiply them? FOIL. Don't overthink it. So we're just going to use FOIL for this part. I'm going to keep the n plus 3 because it is there. It does exist. Whatever I'm foiling needs to stay in parentheses. So I'm going to FOIL this. N squared minus 2n plus 1n minus 2. That all stays in parentheses. I don't like that. Well, let's combine like terms to get n squared minus 1n minus 2. This is why I like doing those two first, because I have it set up now like those last 2 problems. I have the binomial first and then the trinomial. If I had multiplied these 2 first, which would be fine, I would have had n squared plus 4n plus 3, the trinomial, and then the binomial, which is fine, and you are always welcome to rearrange those, but this just sets it up a little bit nicer. So that's how I like to multiply them, but you can choose any way. As I said, this is now just those 2 problems we just did. We need to take the n, distribute through. So we're going to get n cubed minus 1n squared, or just n squared, minus 2n. Then the 3 all the way through, plus 3n squared, minus 3n, minus 6. Guess what I do next? Combine like terms. N cubed, negative n squared, and 3n squared. That's going to give me 2n squared. Negative 2n and negative 3n. That's going to give me negative 5n minus 6. If you had chosen to multiply yours in a different order, do you think you get the same answer? Sure. You can choose whatever order you want. Again, I just think it sets up the problem a little bit nicer to do the last 2 first, then you have a binomial, or here you have a binomial times a trinomial. All right. Let's skip that. Let's do this one. Oh, a little messier looking, but it's stuff we've actually done. It's a little bit quicker than those last ones. It's just messier looking. 2xy times 3x minus y plus 4y squared times x squared plus 6. So a little messier because of the exponents, because of the multiple variables. We're going to distribute. Kaylee, when I distribute the 2xy, what do you think I get in these two terms?
6x squared, and then y,
Good.
and then x,
So,
or 2,
so minus 2.
yeah, and then x, and then y squared.
Good. All right, so there's when I distribute the first pair. Now we're going to distribute here. Emery, can you tell me what I get when I distribute here?
4x squared y squared plus 24y squared.
Good. 4x squared y squared. Then here we get 24y squared. As soon as we get to these problems now that have multiple variables, if you get it out of order, it's okay. But what we like to see is we like to see us pick one variable and get it in order from that variable. So I'm going to pick the x, and I'm going to see what has an x squared and a y. Well, this has x squared y. Does anything else have x squared y? Well, shoot. Well, maybe I need to check to see if there's any other like terms. Does this have a like term, xy squared? Does this have a like term? Well, maybe there was nothing to combine. I got all excited I was going to rearrange stuff and combine stuff. Does that have a like term?
No.
Nothing matched. We've talked about this. They have to match exactly. So at first when I was writing this down, I thought, oh, these two are going to match. No, they don't. Because the exponent on this one was with the x. The exponent here was with the y's. The exponents have to match exactly with the same variables. So that was our answer. Let's do this one, and then I'm going to give you the homework. 2ab times 6a plus b squared times 4a squared minus 1. See if we get any terms we can combine here. 2ab times 6a plus b squared times 4a squared minus 1. Again, it looks messy. Take it a little chunk at a time. Madison, let's have you distribute on the first pair. You can do it. Just a little bit at a time. So what's 2 times 6? Yeah. Okay. Let's.
So I just keep the a.
So if I have an A and an A, it's going to be A squared. And I need the B. Now how about the second term? So this one to the B.
Wait, what are you asking me?
So 2AB times just 1B, what do you get?
2b.
But I need that A in there too. So 2AB squared. So we have to have, you're right, we need a B to the second, but don't forget we still have that A as part of the term. You know what I'm saying? All right, now let's take the B squared all the way through. Tyler, give that a shot for me. So there's no numbers to multiply, so what is the number going to be? Okay. Are there any variables to combine? So how am I going to write it? Yep, and I can write it that way. I personally like to put my a's first, so I'm going to flip it around, write a squared, b squared. But if you put b squared, a squared, that's fine. And then Tyler, what do you think about the last term? Times this. Yeah, so minus 1b squared. Okay, I won't get so excited this time. I'll check my like terms first. So a squared b, is there something that matches? AB squared, is there something that matches? A squared, b squared. B squared. No. That's my answer. Well, I got a little excited in my circling. All right, your homework. You're going to do page 233, one more day. 32 through 39, that's more like what we were just doing. 41 through 47, it is more of that exponent practice. So more things like 3x squared y to the negative third over 12x to the fourth y to the fifth. So just more practice with that kind of stuff. I don't know why it was important, why I felt the need to tell you that, but I did. So you got about 15 minutes, a little less, for you to get a good start on that.